Okay, ladies and gentlemen, so we're going to start talking about stoichiometry. And stoichiometry is a mathematical relationship between elements and compounds in a chemical reaction. So the whole idea, or we'll say main concept of stoichiometry, we need to worry about a mole ratio. And a mole ratio is a conversion factor that relates the amounts in moles of any two substances involved in a chemical reaction. So it comes from the coefficients of a balanced chemical equation. That's why it's so important to have a balanced chemical equation. So now if we look here, if we want, and we see an example, we have the decomposition of aluminum oxide. And if we wanted to show the mole ratio between an aluminum oxide and aluminum, it would be 2 to 4. Now, aluminum oxide to oxygen would be 2 to 3. And if we want to do a mole ratio between our products, aluminum to oxygen, it would be 4 moles of Al to 3 moles of O2. Now, if we wanted to go ahead and do moles to aluminum, it would be 3 moles of O2 over 4 moles of Al. I like to think of this as a bridge or mole ratio. I'm getting from one destination or one unit to another. So the first one, mole to mole calculations. So once again, the first and most important thing is to make sure our equation is balanced. And if I look here, it's not quite balanced. So if I put a 2 here, that'll balance out my nitrogen, and a 3 here, it'll balance out my hydrogen. So now we're good. So it says, how many moles of NH3? And I like to put my variables above. So how many moles? That's what I need to solve for. Are produced when I have 0.60 moles of nitrogen reacts with hydrogen. So just like any other dimensional analysis problem, we're going to write down what we know. And we know 0.60 moles of N2. Now, when you're at moles of your initial reactant or product, think of it that you're at the easy pass station for people that drive, right? And a lot of times before you go over a bridge, you have to go through the easy pass station. So think of the mole as basically your toll plaza for your easy pass. Once we're in moles of our initial reactant or product, then we can use our mole ratio to get to our final reactant or product's destination. So remember, like I said previous page, that our mole ratio is like our bridge. So right now we're at our easy pass station here, and now we're going to go over our bridge. So we're going to go from New Jersey to New York City. So we want to know how many moles of NH3. And remember, our mole ratio comes from our balanced chemical equation. So we're going to have 2 moles of NH3 all over 1 mole of N2. Moles of N2 are gone. We're left in moles of NH3. So it'll be 0.60 times 2. And we'll get, I'll put my answer down here, 1.20 moles NH3. So, 2 problems here. Key thing, remember, always make sure our equation's balanced, and in this case it is. So we know how many moles of water can be formed from 15 moles of hydrogen. So we start with our 15 moles of H2. And we're already at our easy pass station and we're in moles. So we're going to go right to our bridge, our mole ratio. So 2 moles H2O all over 2 moles of H2. Calculate this, we should get 15 moles of H2O. Now the next one, I'll erase this so we don't get confused. Once again, how many moles of water? When we start with 15 moles of oxygen. So 15 moles of oxygen So we see that we're in the mole unit, so we're at our easy pass already. We want to go over our bridge, so 2 moles H2O all over 1 mole O2. And we should get 30 moles H2O. Now we're going to add a gram to here, so mole to gram calculations. So it says in photosynthesis, plants use energy from the sun to produce glucose, C6H12O6, and oxygen from the reaction of carbon dioxide in water. So the first thing we need to do here is we need to create our balanced chemical equation. So we're going to have carbon dioxide and water, so CO2 plus H2O will produce glucose, C6H12O6, and O2. Awesome. So now, once again, make sure it's balanced. So we should have a 6, 6, 1, 6. All right. So it says, what is the mass in grams of glucose when you start with 3 moles of water and react with carbon dioxide? So I'm going to start what they give us. They give us 3 moles of H2O. Once again, we're at our easy pass station, so we can go over our bridge. We can use our mole ratio, and we want to put the number we're trying to find, the mole ratio that we're trying to find, on top. So it's going to be times 1 mole of glucose all over 6 moles H2O. Now they want to know the mass in grams. So how do we figure out the molar mass, or the grams of glucose? Got to figure out its molar mass. So we have 180.18. So we do 3 divided by 6 times 180.18. And we should get 90.09 grams of C6H12O6. Okay, so now, good with this. Now we'll do one more example here for gram to mole. So the first step in the industrial manufacture of nitric acid is the catalytic oxidation of ammonia. So it tells us our equation's unbalanced. So that's the first thing we need to do here. So let's try to balance this equation. So let's try to put a 3 here. Let's put a 2 here. And let's see where we are. So we have 2 nitrogen on this side, 2 nitrogens on this side, so we're good with those. 6 on this side. 6 hydrogens on this side, so we're good. But now we only have 5 oxygens on the right side and 2 on the left. So what are we going to need to do here? So there's something wrong with this equation. Remember, we can never have a fraction as our coefficient. Because I look here, I have 5 on this side and 2 on this side, and 2 times what gives me 5, so it'll be 2.5. So I need to balance everything, multiply everything by 2. So I'm going to have 4, 5, 4, 6. Now we're balanced. So it says the reaction is run using 824 grams of NH3. And it says how many moles of NO are formed and how many moles of H2O. So 2 separate problems we have here. So we're both going to start with our 824 grams of NH3. So times 1 mole NH3 all over 17.04 grams of NH3. So now we're at our NH3 easy pass. We need to go over our bridge. So we want to go to moles of NO in this first one. So we're going to have 4 moles of NO all over 4 moles NH3. So we have 824 divided by 17.04 times 4 divided by 4, and we'll get, I'll put this up here, 48.36 moles NO. Now the next one, we start with the 824 grams of NH3. Same first step. Okay, get this out of the way. Okay. Now, same thing, mole ratio. So we need to go over our bridge. We're at our easy pass station. So we're going to go 6 moles of H2O over 4 moles NH3. So 824 divided by 17.04 times 6 divided by 4, which gives us 72.54 moles H2O. So we got mole to mole, gram to mole, mole to gram. In the last part of this video, we're going to talk about gram to gram. So it says, calculate the number of grams of NH3 produced by the reaction of 5.40 grams of H2 hydrogen with an excess of nitrogen. So we start with what they give us. They give us 5.40 grams of H2 times 1 mole of H2 all over 2.02 grams H2. Now, we're at our easy pass station. We want to go over our bridge. So we have 2 moles NH3 all over 3 moles of H2. Now, since it's a gram to gram problem, our last step is to go to grams of So we have 17.04 grams of NH3 all over 1 mole of NH3. So we have 5.40 divided by 2.02, it equals, times 2, it equals, divided by 3, it equals, and then times 17.04, and you should get around 30.37 grams of NH3. And the last one here, that's a grand bowl problem. It says phosphorus burns in air to produce a phosphorus oxide in the following reaction. So it says what mass of phosphorus, so that's our gram, will be needed to produce 3.25 moles of P4O10. So we have 3.25 moles P4O10. We're already in our easy pass station here. We could use our mole ratio or our bridge. So go over our bridge. So 4 moles of phosphorus all over 1 mole of P4O10. Now we want to go to grams, so it'll be 1 mole of phosphorus on the bottom. And then just plain phosphorus P, excuse me, P will be 30.97. Grams of phosphorus. So plug this in our calculator. So we have 3.25 times 4 times 30.97. And we get 402.61 grams of phosphorus. And this concludes our first stoichiometry video.